Good morning, students. In the previous class, this problem was incomplete. This is for polarization. It is not there for Karnataka CET examination. CET it is not there. It is only for NEET and JEE. In this question, axis of the polarizer and analyzer are inclined by 6 degrees. A is the ampere of the unpolarized light entering. This is A0. Unpolarized incident on the polarizer. Find the ampere of the light transmitted at the transmitted out of the analyzer. Polarizer, analyzer are nothing but polarites only. Both are same only. But if you convert unpolarized to polarized light, it is called as a polarizer. If already polarized light is there, to check up whether the polarized light is not, is a polarization light is polarized or not, you are verifying it. That is second one polarized is called as a analyzer. This light is called as a analyzer. So first polarized is polarizer, second polarized is analyzer. The light passing in incident is unpolarized, so intensity is I0. The amplitude is A0, is given as A for us. So I0 is intensity is proportional to square of the amplitude. I0 is proportional to A square, A0 square. And after passing through this first polarized, that is polarizer, intensity becomes half of the initial intensity. So intensity is I1 equal to unpolarized light intensity I0 by 2. Then amplitude becomes equal to this I1 is proportional to A1 square, I0 is proportional to A0 square. Proportionality constant will be cancelled left and right side, and you will get is I1 square equal to A0 square by 2. So A1, if you want to get, this is the first polarizer. After polarizer, the amplitude becomes equal to A0 by root 2. Intensity is half, but amplitude is not half, it is A0 by root 2 it becomes. Next is polarized light. Now polarized light passing through the analyzer, you have to use the law of Malus or Malus law. What is Malus law is the intensity coming out of the transmitter out of the analyzer E is equals to the intensity entering, there is a polarized light intensity entering the analyzer into cos square theta. Theta is the angle between the two axes of the polarizer and analyzer axis. If you take this initial angle as 0, whatever the reference, doesn't matter, no need to mention also. Angle between these two axes of the polarizing axis of the each polarized angle is inclined by some angle theta with respect to each other. Then this I2 we have to find out, A2 we are asked to find out. I2 equal to I1 into cos square theta. I2 is proportional to A2 square, I1 is proportional to A0 square into cos square theta. I have written the same thing here. The intensity of the light coming out of the analyzer is I2 equal to I1 into cos square theta. So I2 equal to I1 is nothing but I0 by 2 into cos square theta. I2 is A2 square equal to I0 is A0 square by 2 into cos square theta. Theta is 60 degrees, you can substitute here only, doesn't matter. 60, cos 60 is half. So this root if you remove, square if you remove, no, A2 equal to A0 by root 2 into cos square 60, no, root it comes, means cos 60. Cos 60 is half. That means A2 equal to A0 by 2 root 2 is the answer for this question. You can take any number of the polarites. If you take the two polarites, the angle between the polarites is 90 degrees. Then the intensity of light coming out will be 0. You will be given a problem like two polarites are crossed. Crossed in the sense this polarite is making angle 90 degrees with respect to the previous polarite. So what is the intensity of light coming out is equals to this I1. So I0, I1, I2 is 0 because theta is 90 degrees. Now third polarite is kept in between at some other angle. Generally they will give the problem, repeatedly asked problem is 45 degrees. So with respect to these two 45, between these two also 45. Now previously intensity was 0 here, but in this case intensity is coming again from this third pole. That previous second one becomes now third pole, right? Now analyzer it's called as a polarizer, analyzer, analyzers. The light intensity coming out of the second polarized is third polarized is not a 0. Only these two are there. Theta is 90 means intensity is 0. Now whenever the third one more polarized is introduced in between, the intensity of the transmit light out of the complete system is not equal to 0. Again you have to take the help of the Malus law. This I1 becomes equal to I0. Between these two you will get is I1 equal to I0 by 2, and between these two you have to apply law of Malus. I2 equal to I1, this intensity I1 into cos square 45 degrees. This angle between these two is 45 degrees. And intensity coming out of the third polarized is I3 now. What is I3 becomes is I3 equal to the intensity before is I2 into cos square angle between these two in this case is 45 degrees. So whenever you get the cross polarized, the intensity coming out is 0. But if we introduce one more polarized in between at some other angle, not 90 degrees between these two. If these two 90 degrees means the intensity between these two is 0, between these two also 0. Then if the third pole, one more polarizer introduced in between the crossed polarites, the intensity coming out of the system will not be 0. The condition is that between the first two polarites that it is not 90 degrees. Then you apply the law of Malus in the leaving the first two, you have to apply here and here to get the final intensity. If they ask the percentage of the transmitted light compared to the incident, no, complete output I3 by I0 into 100%. If they have the percentage, they ask the fraction only. Fraction of the intensity coming out means don't multiply with 100%, just output final by initial input, that is unpolarized intensity, is nothing but equal to fraction of the intensity of light coming out. If they ask the percentage of coming out is into 100%. Next is Fresnel distance. Before going to that, one more point related to this polarizer linked to the total internal reflection. They will ask you TIR means total internal reflection. This will be coming to us in the ray optics also, but that formula linked with the polarization they may ask you. If the light is transmitted from rarer to denser medium, say air to water or glass. In the case of the rarer medium, molecules are far away from each other. In the case of the denser medium, molecules are close to each other. So light has to collide with the more atoms, so its speed will be reduced. Velocity of light is less in the denser medium compared to rarer medium. That density called as optical density is compared with the constant value called as a refractive index, mu1 and mu2. Refractive index and velocity is inversely related. More refractive index means less velocity. More optical denser, less velocity. So light when traveling from rarer to denser medium, it deviates towards the normal. This is the angle of incidence, this is the angle of refraction. The angle between the incident direction and final refract direction is called as the angle of deviation. In this case, deviation angle is nothing but equal to I minus R, large minus smaller angles. In case if you take the reverse case, light traveling from denser to rarer medium, we'll take in reverse better. If light is traveling from denser to rarer medium, this is the angle of incidence. The light traveling to rarer medium, it deviates away from the normal, this R. R is more than I, the deviation is supposed to go straight, this is the angle of deviation. Deviation is nothing but equal to I minus R you will get. And for polarized light, in case if you are getting this, some light is transmitted, some light is reflected, the angle between these two is 90 degrees in such cases given, then angle of refraction plus polarizing angle, means angle of incidence, is nothing but equal to 90 degrees. These two equations you have to combine to get the problems. And this theta p is nothing but equal to angle of incidence to get the polarized light. Bruce's law, tan theta p is equals to mu2 by mu1. Next is Snell's law also you can use. One more thing is tan theta p is equals to mu2 by mu1. If mu1 is air means mu2 becomes equal to mu only. If the light is traveling from rarer to denser medium, otherwise reverse cases it will not be equal to mu. We just check up the relation, 1 by mu you may get. Next is Snell's law. What is Snell's law of refraction is sin I by sin R is nothing but equal to mu2 by mu1. Second medium refractive index by first medium refractive index. Refractive index inversely proportional to velocity, so V2 V1 by V2. V equal to F lambda. Frequency remains constant during the refraction and also during reflection. Frequency of light do not change. Frequency, color depends on the frequency. Color of light depends on the frequency. Color also do not change during refraction and reflections. So mu inversely proportional to velocity. Mu2 by mu1 equal to V1 by V2. V equal to F lambda. F is constant here. Therefore lambda 1 by lambda 2 you have to get. Frequency F is constant. This is Snell's law we use. Snell's law is not applicable if I is equal to 0, R equal to 0. When the light falls normally in perpendicular surfaces along the normal, if it falls, Snell's law is not applicable. In the Snell's law part actually related to the refractant index, but this all relation remaining except the sin A by sin R, remaining part is applicable always. Next, this Snell's law is applicable when the light is traveling from rarer to denser or denser to rarer. But here, for the second case, when the light is traveling from denser to rarer medium, if angle of incidence increases, I increases, R also keeps on increasing. At a particular angle of incidence, if I increases, R increases, at a particular angle of incidence, I keeps on increasing like this, R also increases. At a particular angle of incidence called as a critical angle, this is equals to called as a theta c. I will give you, they will give it as a c, but don't get confused with the speed of light c. So I am mentioning it as a theta c. I is equals to theta c, angle of incidence, and the angle of refraction becomes equal to 90 degrees. This is normal between the two surfaces. This is going to be R. Whenever the I is equals to theta c critical angle, the angle of refraction in the second medium becomes equal to 90 degrees. The light is not going to the second medium, not coming to the first medium, it is going along the surface called as grazing. It grazes the surface. It's a medium 2, supposed to be rarer medium, this is supposed to be denser medium. Condition compulsory, light traveling from denser to rarer only it happens, in reverse case it won't happen. So Snell's law, if you take a sin I by sin R is equals to n2 by n1 or mu2 by mu1. Refractant index, this is n2, this is n1, or this is going to be n rarer and n densers. Sin A by sin R, light is traveling from denser to rarer, therefore second medium is rarer medium. N rarer or mu rarer symbols by n denser medium. Inversely related to the velocities. So velocity of the denser by velocity of the rarer medium is also equal to V equal to f lambda, lambda denser by lambda rarer medium. But in this case R is 90 degrees. When I is equals to theta p, theta c critical angle, R is 90, sin nt is 1. So what you can simply take is sin theta c is equals to n rarer by n denser is equals to V denser by V rarer equal to lambda denser by lambda rarer. This relation you have to take care to while doing the problems of the polarization. There we have got the Brewster's law. What is Brewster's law is? Tan theta p is a polarizing angle. E is equals to mu2 by mu1. Now in this case I am giving the symbol n1 and n2 for the refractant indexes. So it is going to be n2 by n1. This n1 by n2 or n2 by n1. If it is traveling from denser to rarer, second is rarer by denser. If it is traveling from rarer to denser, that second medium denser by rarer. Reverse relation you have to take up. And these two comparison problems will be asked sometimes. Next is Fresnel distance. Fresnel is the name of scientist, Fresnel also we can call Fresnel distance. In case if you take the light according to the ray optics given by the Newton called as the corpuscular theory, light travels in the form of the straight line paths because he imagined that the light is because the particles, small particles, he called them as corpuscles, and size of the particles determines the color. According to the Newton, the bigger particles have the appear to us as a red color light, and smaller particles appears as a blue, violet or blue color lights. So wavelength we are discussing later, that is given by the Huygens, but Newton gave that ray optics are called as geometrical optics. Light travels in the form of the straight line path because they are particles not affected by the gravity, so they go in a straight line path according to the Newton. So here how long, but this is according to the ray optics, but actually we know that light travels in the form of the wave optics. If any obstacle comes, the waves bend but not particles, means rays do not bend along the surface of the obstacle, but waves bend along the surface of the obstacle. That bending is a diffraction we call. Diffraction effect is well observed when the wavelength is in the order of the apertures, or if you take the plate and make a hole or slit you can take. When light is passing from here, you switch on the torchlight here, or even if you take the torchlight outlet, light do not come straight line path, it will go straight line from distance, thereafter it goes bending. Here same thing for the hole. If you take, if the light is coming parallel here, how much distance it travels parallel, afterwards some distance it compulsory deviates, of course. From here only it starts, but less amount of deviation you will find at the obstacle. As it goes, if the deviation increases by large amount, up to the distance So up to what distance the light is traveling straight line path, means obeying the ray optics. Thereafter it is violating the ray optics and following the wave optics. So up to this it's almost straight line. The distance is called as a Fresnel distance. So we take it as a ZF. The aperture side, it can be a slit or circular hole. The aperture size is A. Same thing for the torchlight outlet. What you are taking, the output light coming out, that's this aperture. The outlet is nothing but equal to A. If it is circular, diameter we need to consider as aperture. So it is a distance up to which the ray optics is obeyed. Thereafter it obeys the wave optics. The distance is called as a Fresnel distance. The Fresnel distance depends on A and thereafter it spreads. What is the Fresnel distance is nothing but equal to, depends on the wavelength also, E is equals to A square by lambda. It's just like a D, capital D we have taken previously. Here also you take ZF is nothing but equal to A square by lambda. That's total separation you have to take. Our aperture size we can also take it as A. The problem number based on this, we have material problem 2, 3, 4, fifth problem. For what distance ray optics is a good approximation? When the aperture is 3 millimeters, you are given aperture size A equal to 3 millimeters. Aperture size is 3 millimeters. And lambda is, wavelength is 500 nanometers. Up to what distance is ray optics is approximately considered, is obeyed, you can say. That is a Fresnel distance. That Fresnel distance is nothing but equal to A square by lambda, which is A square, 3 into 10 to the power of minus 3, 3 into 10 to the power of minus 3 by lambda is 500 into 10 to the power of minus 9. Minus 9 take it to the numerator becomes equal to plus 9. Minus 6 plus 9 is plus 3. So what you get here is 3 3 is a 9. 9 by 5 into 10 to the power of minus 6. Minus 6 plus 9 is plus 3 by 500, sorry, by 10 to the power of 2 I separated. Minus 2 means 90 by 5 will get. By 5, that is equals to 18 meters. Up to 18 meters, the light travels almost a straight line path, means deviation is less. This is nothing but equal to ZF. Thereafter, it deviates more. This is the aperture. It's actually traveling like waves, but almost like a straight line, applicable as a ray optics up to distance equal to ZF. And in case if you take the cell phone signals, sometimes if there is a hill or a building in the path of the waves coming from the antenna or towers of the say cell phone towers, the tower is located here, the transmission tower. From here the signals are coming. There is a hill or building is there. These signals of high frequency, as the frequency increases, the electromagnetic waves travel in a straight line path called as rectilinear propagation. As the more frequency increases, more straight line path. Low frequency waves can bend on the surface of the earth, along the surface of the earth also. If the earth is spherical, if the antenna is here, the longer wavelengths, low frequency waves can bend along the earth, and if your house is here also you can receive the signals, but not high frequency signals. Low frequency signals are radio waves, radio waves of medium waves. But if you take the FM waves or cell phone, mobile phone waves, TV waves, there are the high frequencies. They travel in a straight line path. They try to go in a straight line path. If they in the straight line path only, if your house is located, then you can receive, otherwise you cannot receive. If any building comes in between also, you cannot cover it. So if your house is located here, the low frequency waves can receive the signals. But high frequency waves go straight line path, they cannot receive it. Such cases what you do, some people will go top of the buildings, putting the cell phone up, or go on to the top of the tree to receive the signals which is coming on a path. Okay, so in this case, even though they are traveling in a straight line path, they do bend because they are also waves. By up to some distance, they will travel in straight line path. So after what distance they are able to bend? When the obstacle is here, the tower is here, and your house is located here. So you have to check up this belt. These are hill in pitch path. So the waves travel in straight line path, but bend by small amount. If you are keep antenna tall enough to receive or touch these waves, you can receive that signal. So up to what distance they travel in a straight line path is nothing but equal to Fresnel distance. Next one is Doppler effect. Doppler was first observed by Doppler scientist for the sound waves near railway station. If the sound producing source is approaching you, or observer who is observing that sound person is running towards the source, then the frequency of the waves appear to change. That is called as a Doppler effect. The apparent frequency that appears to us is called as apparent frequency. The original frequency is different. What we hear is different. The change in apparent frequency due to relative motion of source and observer is called as Doppler effect. The Fresnel distance and Doppler effect are important for all examinations. CET also, NEET also, JEE also. The change in the apparent frequency due to the relative motion of the source and observer is called as a Doppler effect. This is applicable for sound and light with small variations for the light. Sound waves is very small velocity we have. Velocity of the sound, if you take the sound, velocity V equal to F lambda applicable in all the cases, please. But the frequency range, audible frequency range, what we can hear is called as audible frequency range. Frequency is between frequency is equals to 20 hertz to 20 kilohertz, means 20,000 hertz. Even though it is mentioned, it is not applicable for all the eardrums. Only infants can hear this lowest and highest. Children, as the age increases, the frequency range goes on decreasing. This is audible frequency. Less than frequency less than 20 hertz are called as infrasonics. Whenever the word sonic is used, the word sonic, it is related to sound. Son is a word, French word, it means sound related and hearing also. Sonic word is there, means it is related to sound. If the frequency is more than 20 kilohertz, it is called as ultrasonics. Ultrasonic. If the speed is of any object, speed of the object is greater than speed of the sound, it is called as a it's called as a supersonic. Careful with the word, it is related to sound only. Supersonic. And when you ask about the polarization, only transverse waves can be polarized. All these are the sound waves. Sound waves are, these are the transverse. The wave energy vibrates perpendicular direction of propagation is a transverse. And the only transverse waves can be polarized. But if you take the longitudinal waves like a spring waves, they have the compressions and rarefactions. And compressions, rarefactions. The compression rarefaction molecules oscillate to and fro. Energy also propagated in the same directions. This is called as the longitudinal waves. Longitudinal waves cannot be polarized, but transverse waves can be polarized. All these are related to sound waves, cannot be polarized. And supersonic, however, it is not related to sound. It is not sound waves. It is related to the objects which are moving with the speed greater than the sound. They are called as supersonic. Less than sound is called as subsonic. Equal to sound is called as sonic speeds. This is related to the frequencies. For them, you can calculate the wavelengths for the problem's purpose. If they ask lambda equal to V by F. What is the velocity of the sound is? Velocity of the sound is 330 meter per second at 0 degree centigrade to maybe at high temperature summer seasons. It can reach near to 350 or just 354 meters per second in range approximately. Generally, we use if they don't give, use the 330 meter per second. This is velocity of the sound. But if you talk about the velocity of the light, velocity of the light is very high. Speed of light is light speed in vacuum is 3 into 10 to the power of 8 meter per second. speed is very high, okay, and frequency also varies for these cases. C equal to f lambda applicable for the light waves also. If the medium is denser medium is means speed is decreased, but in this Doppler effect applicable for the sound waves also, light waves also. But the light speed is very high compared to that of sound. So condition for the Doppler effect, what is that condition is? We are taking the two frequencies. One is a source frequency, another one is observed frequency. If there is a bell ringing, it's the original frequency. The person is standing here and is the observer velocity. This is called as the source velocity. This is the frequency of the sound produced. Wavelength is lambda. If the source moves, then lambda is changing in the medium. If the observer moves, there is no change in lambda. But person what he is listening is called as the apparent frequency f prime. If both are at rest, f equal to f prime only. If observer is moving towards or source is moving towards or away, the frequency changes called as the apparent frequency. The apparent frequency is nothing but equal to this called as apparent frequency is nothing but equal to original frequency into C plus or minus VO by C minus or plus Vs. It's a general formula for the apparent frequency. VO is a observer velocity, Vs is a source velocity, means source is in motion. If observer is at rest, VO is 0. If source at rest, Vs is 0. C is the speed of the sound in this formula of sound. That is 330 meter per second at 0 degree centigrade approximately. Change in frequency is nothing but equal to f prime if the minus f. If they are approaching, anyone approaching towards each other, either VO moving or Vs moving or both moving towards each other, the frequency increases. Frequency means apparent wavelength also appear to be decreasing. If they are moving away from each other, the frequency decreases. Minus, if they are approaching, you have to take the plus numerator, minus in the denominator. If they are going away, anyone is going away, then you have to take the minus in the numerator, plus in the denominator. Source at rest, Vs 0. Observer at rest, VO 0. So we take the, for the light case, if you take the observer velocity is very less compared to the speed of the light. Same formula for the speed of light with the little modification you have to use. And here C is the speed of the sound I mentioned for this formula, that can be changed to speed of the light. Observer velocity is condition for the Doppler effect to be applied for the sound is observer velocity should be compulsory less than that of the source velocity also. Observer velocity must be less than the speed of the light sound, compulsory applicable, then only it is applicable. Equal to also okay applicable, but should not be more than. Compulsory VO or Vs should be less than the speed of the sound to apply the Doppler effect. That is a limitation place. But if you take the light, if you take the Doppler effect, light speed is very high. Observer, where you observe means where we cannot run on the earth compared to the speed of the stars, light coming from the stars, or the speed of the light is very high. So in that case, what you take is the earth velocity with respect to the stars. This Doppler effect in light mainly applicable for the stars velocities finding cases or aeroplane finding cases with the help of the radars we use. So in the case of the light, we take the modification of this formula. If you take this same formula I am writing here, f prime equal to f into C plus VO by C for the Vs at rest if you have taken, and we make the modifications later. This can be written as f into 1 plus VO by C. Expand it further, f plus f into VO by C. If the frequency changing, we can take this f to the left side, f minus f by f. F minus f by, take it to the left side is f equal to VO by C. This is called as a delta f or change in frequency by initial frequency, relative changes equal to V naught by C. Or we can take it as a differentiation if you take the term called as a df, frequency change. This is a constant. Okay, and differential of the constant is 0. So differential of, here also f is constant. So initial frequency, the actual frequency, original frequency is constant. So Vf into dVo by C. So the df by f is nothing but equal to, this formula becomes equal to f I taken to the left side, dVo by C. This is taken as a delta f by f is equals to delta VO. dVo is now taken as a change in velocity. This means relative change in velocity is taken as a d radial velocity called as radial velocity or relative velocity by C. This formula you have to learn. But frequency is inversely proportional to C equal to f lambda, or f is equals to C by lambda, or C into lambda to the power of minus 1. So delta f by, delta f you have taken means what you get is 1 by delta lambda, reverse of the lambda you have to get. So we'll get this formula becomes equal to, this formula is also equal to delta lambda by lambda with the negative sign. Here this delta f, we are taking only one condition here, they may go towards or away, no. The basic formula we are taken is equals to minus sign here. If the frequency approaching means frequency increases, going away means frequency decreases. So if the velocity, if you are calculating radial velocity, why it is called radial velocity? Relative velocity is nothing but radial velocity. The star is approaching you. It might be going any direction also if the person is here on that. So the change in frequency, if you take the differentiation, is equals to radial velocity by c, which is equals to change in wavelength by lambda. Negative sign indicates that if the frequency increases, wavelength decreases. And also this minus sign, because the radial velocity, what the velocities, if the star is going away from you, you will get the velocity as a positive. If they are approaching you, take it as a minus. And if the star is approaching the person on the earth or towards earth, approaching means the frequency increases. When the frequency increases, wavelength decreases. Frequency increasing means in the WIBGR checkup, approaching frequency increase, wavelength decrease. In the WIBGR spectrum, towards that wavelength increases and frequency increases towards violet, opposite side. So if some star is producing some particular color, the wavelength appears to be shifting towards other colors. If the star is approaching you, the frequency increases means it is shifting towards the blue. It's called as a blue shift. And if it is star is going away from you, if the star is going away from you, that supports the expansion of the universe generally. If going away from you means the wavelength frequency decrease and wavelength increased, that is called as a red shift. So this formula is used to find the speed of the stars generally, or even the radar's motion. With the help of the radar, speed of the aeroplane also will be considered, but that I will give you the formula later directly in the material only. One problem is there linked to this speed of the stars. We will work out that. In the examination, theory exam also, this is important only, but they don't ask you the derivation. They ask directly application from delta f by f equal to radial velocity by c. Why it is called radial velocity? Star might be going in the different directions. Actually, they are revolving around the center of the galaxy, all the stars, including our sun. And then in that case, what happens if the star is going in directions? The person is on this earth. The star is going, or the light source is going in any direction, so maybe, but waves are coming like this. So if you imagine that at that instant, this is called as a circular path. If you have taken, the wave is going along the radius of the circle towards the person. Then in that case, this is velocity, relative velocity comparison, these two, observer and source. This observer is the person, source is the light emitting ones. The radial velocity along this comparatively, what is observed is called as a relative velocity is called as a radial velocity. It is also equal to relative velocity. In this material, the third question is asking which one is cannot be polarized. Cannot be is negative ones. Gamma rays transverse, all electromagnetic waves are transverse. X-ray rays also transverses, they can be polarized. Green light polarized, ultraviolet light polarized, ultrasonic. Sonic word is that means sound waves are longitudinal, they cannot be polarized. Next question is fourth question. Fourth question, what is the speed of the galaxy with respect to the earth? Find speed of galaxy with respect to earth. If lambda is equals to, if lambda wavelength shifts from 589 nanometers to 589.6 nanometers for observer on earth. Okay. What is the formula we have is answer data lambda delta lambda. You have to take the shift in values. Shift in wavelength is 589.6 nanometers. 589 in 0.6. Sorry, minus 589 nanometers, which is equals to 0.6 nanometers, which is 0.6 into 10 to the power of 9 meters is a shift. There is a shift in the wavelength. And what is the formula for the Doppler effect in light we have is delta f by f is equals to minus delta lambda by lambda is also equal to v radial velocity minus by c. C is nothing but equal to speed of light in vacuum 3 into 10 to the power of 8 meter per second. You are asked to find v radial velocity equal to how much? Speed of the galaxy is nothing but equal to radial velocity. speed of the observer or speed of the galaxy together, you have to take the combined velocity, that is called, we call it as radial velocity, or we call it as a relative velocities, equal to how much. This is the formula we are using, and if they give frequency, use this relationship, but they asked this, they gave in terms of the lambda, so we need to consider this relationship, delta lambda by lambda equal to radial velocity by c. This lambda terms, what is lambda? Initial lambda, denominator must be initial lambda ones. So lambda 1 is nothing but equal to 589 initial value nanometers. Here lambda is increasing, means frequency is decreasing. Frequency increases means approaching, frequency decreasing means increasing cases. So we take the relation for this delta lambda by lambda 1, E is equals to minus minus cancels, radial velocity by c, which is equals to delta lambda is 0.6 nanometers, 9 by lambda 1 is 589 nanometers, E is equals to v radial by speed of light is 3 to the power of 8 meter per second. So you will get the radial velocity by calculations, 9 cancels, the answer is v radial, E is equals to you will get the answer from this v radial, you just calculate that, velocity is equals to 306, 3.06, positive you are getting 3.06 into 10 to the power of 5 meter per second, which is, if you change the two digits, no, 306 into 10 to the power of 3 meter per second, 10 to the power of 3 means kilometers, 306 kilometers per second is the speed of the galaxies. Plus is coming means away from the earth, directed going away from earth. According to Big Bang theory, the expansion of the universe means it exploded, all the stars exploded and going away from each other is what the scientists, some scientists think. So according to this, if they are going away means the wavelength should increase, called as the redshift. But some are going away means some may come out, that is one of the theory place. Yeah, going away from earth is the answer. One more thing is that frequency is called as a pitch. This is for the sound, and same term we can use it for the colors. This is for the light. Colors don't have the single wavelength, please. Red color itself is a band of the wavelengths. So if we use the word pitch, pitch means frequency, high pitch, low pitch, the term used in the sound. The pitch is a term used in the sound to refer the frequency. What is the other term we use in the light to refer the frequency is color. Means red color, blue color we say, but actually we don't say specifically what is the frequency. Red color is range, we get it up, range of the wavelengths only. So the pitch is a term used for the frequency or apparent frequency, what appears to us in the sounds. Similar term used in the color is light, but sound is a longitudinal waves. Sound in the air is longitudinal, but sound waves in the solids, like earthquake waves in the solids, stones, the sound is both the transverse as well as longitudinal. Here we are discussing is only in the air cases, sound means longitudinal, cannot be polarized, but light is a transverse which can be polarized. Okay, with this topic is finished. Any doubts you can ask on the net.